So let's look at identifying repeating decimals as fractions. So all that matters is that you identify how many places are repeating, whether it's one place or two places or three places. So in this case, the pattern is two of the places are repeating, so just the 4-0, but not the 8. And based on the number of places repeating, we're going to multiply by a corresponding power of 10. So if one place was repeating, we would multiply by 10. Two places are repeating, we'd multiply by 100. Three places repeating, we'd multiply by 1,000, and so on. And this is to line up that repeating part because this forever is a problem. So the way I do it is I call that original number x. And then in this case, since there's two places, I'm going to choose to multiply by 100. So I want to know what is 100x. 100x just shifts the decimal point, so that would be 84.0404, and so on. And what we're going to do is we're going to subtract our original number from that. My original number, and line up the decimals to subtract, right? So that would be 84040. And what's going to happen is, because I picked the right power of 10 to multiply by, the decimals in that forever part are lining up. And I just want to subtract away that forever because it's troublesome. So I'm just going to subtract on both sides here. So 100x minus x is going to give me 99 x's. And on the other side, we've got 84 minus 0, which is 84. We have 0. Oops, I was a little premature on that one. I got to borrow over here. The main idea is that this eventually these line up on the right. So 4 hundredths minus 4 hundredths is 0 hundredths. 0 minus 0 is 0. 4 minus 4 is 0. So now I have forever zeros, which is no big whoop. All right, let's fix this. I got to borrow from the 4 there. 10 minus 8 is 2. 3 minus 0. So I get 83.2. Solving for x, I get x is 83.2 over 99. That's not a proper fraction. So I'll multiply top and bottom by 10. And now I can say 832 over 990 ought to be this crazy decimal that repeats forever. I can reduce this, I might as well do that. So for sure I can see a 2 goes in the top and bottom. So what do we get? We get half of that, which is 416 over, let's see, I better double check this one. 2 goes into 9 4 times with 1 left over. 2 goes into 19 9 times with 1 left over, and then 5. There may be a common factor, but I'm thinking not. So my belief is that this fraction right here, if I type it into my calculator, will give exactly that decimal right there, which is a problem because it goes on forever. So my choice is either to write it as a fraction or to round it somewhere in order to use it. So identifying the number of repeating decimals is the key in finding the corresponding power of 10.